Alright, this video is gonna be covering this small portion. So this is the whole circuit diagram for the GravBot robot, and this portion is the battery, showing the battery. So we need to understand why we are using this battery for this project. For that, we need to know what each parameter or each rating of this battery mean. So let's start with the battery and charger section. So the battery, so this is the battery, this is our battery. So this is the G3S LiPo battery pack, 11.1 volt, 5200 milliampere and 50C. And so this battery is a pretty common one because it's mainly used in systems that need around 12 volt of voltage and can draw high level of current. And this is especially used in like motor-based systems. So this is pretty good one for robot design and normal robot running. So let's look into the into ratings and explain or interpret each of this. So this battery is a 3S as a 3S LiPo battery. So this means that this has 3 lithium polymer batteries that are connected in series, and so basically this is a battery pack consisting of three different batteries. And each LiPo battery's nominal voltage is 3.7 volt. So the total nominal voltage will be 3 times 3.7, which is 11.1, and that's why we have this rating 11.1 voltage. Now, this is the nominal voltage, but when we charge a battery to the full capacity, then its voltage is 4.2 volt. And then for the pack, it's going to be 3 times 4.2, which is 12.6. So we can, with this battery pack, we can achieve a maximum of 12.6 volt. Now, next thing, for this battery packs, the safe for each of the batteries, the safe cutoff voltage for discharge is 3.3 to 3.5 volt. So we need to make sure that we charge the battery pack to that level so that at least 10 to 10.5 volt is there to ensure that the running is safe. So these are all important considerations when we are using this battery. Now let's move on to the next one about the battery capacity, which is the most important one, because this is something that we need for running our system, our mechatronic system. So so here the 5200 milliampere hour. So what does it mean? It basically is 5.2 milliampere, and it means that it can supply 5.2. This would be, let me correct this. This is gonna be this is gonna be ampere. Oh no, this is gonna be ampere. Oh no, what's just happening? Yeah, so this is gonna be ampere hour. So it means that this battery can supply 5.2 ampere for 1 hour and 2.6 ampere for 2 hours, 1.4 ampere for 3 hours. So basically the multiplication of these two numbers has to be this. So that's how we can split it indefinitely. Similarly, we can supply more current. It can be double of this one, 10.4 ampere, but the time will be limited, divided by 2. Similarly, 20.8 ampere for 15 minutes. But here is the consideration that we need to we really need to think about or figure out is like how much is the maximum current we can use. So this current drawn from the battery, the current that is supplied by the battery, it highly depends on the load that is connected to the battery. So here we have, with this battery, we have all these loads connected, and all of these like cumulatively determines how much of the current will be drawn or supplied. We need the battery to supply. So it depends on the load. But we are interested to know what's the maximum current can it supply. Then it helps us to design and understand that, okay, if we have this battery or if we have this level of load, whether this battery can be used, whether this battery can supply the required current. So we can also calculate that, and for calculating that, we need to check this value, this 50C. So this 50C provides the discharge information or the maximum current that we can supply. So 50C, like this rating, if this is more, then we can supply more, the maximum current supplied can be more. If this is less, the maximum supplied current will be less. So how this is calculated? So this is the maximum current. The theoretical value is calculated by multiplying this value, this 50C, with the capacity, and this is 260 ampere. So 260 ampere is our maximum current that we can supply. Now this is in practice. So all right. So yeah, in practice, so this is the theoretical value, but in practice we would demand less than that, because in the system there are loss of current because of the wiring and other components. So for safety, we have to consider a safety factor, and probably would not want to use 260 because it cannot supply the ideal theoretical 260 ampere. But we kind of know that what is roughly the maximum current that can be supplied by this battery. Now the total energy storage, which can be calculated by multiplying the capacity and the voltage, which is 52.72 watt hour. This is also provided here, 52.72 watt hour. So this is like a redundant rating. We can basically calculate this using this one and that one. Now let's come to the charger. So when we have this battery, we need to regularly charge it, and for that we need a charger. So how we select the charger, that's another question. So here for this project we have used this charger, the B3 Pro Max balance charger for LiPo battery. Here the input voltage is 100 to 200 volt AC, 50 or 60 hertz, which is the very normal input voltage, but the more important output or rating is the output current, which is 3 into 1000 milliampere. So 1000 milliampere, basically 1 ampere. So 3 into 1 ampere. So this is the rating. So this basically means that this battery that has three different batteries. This pack that has 3 different batteries. Each of this battery can get 1 ampere current. It can supply 1 ampere current. So the charging rate is gonna be 1 ampere. Now it also means that to fully charge the battery pack, this charger will take this time. So the capacity over the 1 ampere, this thing, and if we divide it, then we get 5.2. So the fully charging will take 5.2 ampere at 1 ampere output rate. This also gives us some. So the battery itself provides us some requirement, like what is the maximum value of output that we can allow. So because the battery is the capacity is 5.2 ampere hour, so one C charge current is gonna be 5.2 ampere. So then I can get maximum of 3 into 5.2 ampere output charger. So here this one is currently 1 ampere, but we can make it like 2 ampere, 3 ampere, up to 5 amperes, 5.2 ampere. So if it's 5.2 ampere, then like the charging will be really fast. And right now, because this is 1 ampere, it's actually safe and slow charging. It's going to be charging really slow, but it still works.